In today's tutorial we will have a closer look at the Stetter reaction. We start with benzaldehyde, acrylonitrile, and in the presence of a base and a catalyst, this time a thiazolium salt, we end up with this product, structure D, and a strange reaction has taken place, because if we combine those two molecules, this center and that center, this doesn't fit, because we have electron deficient carbon. Here it is an electrophile, and also here this carbon is also an electrophile. Electrophile and electrophile, that doesn't fit. We need a nucleophilic center here to react in the beta position of that alpha beta unsaturated nitrile. So we need something we call an umpolung, reactivity umpolung. How can we achieve that? Well, with that type of catalyst. So we have a base, but we have there an acidic hydrogen in benzaldehyde. In acrylonitrile we have a slight acidity with that hydrogen, but clearly this one that hydrogen is more acidic. If we deprotonate C with a base, then we get to this structure with a negative charge here at that carbon, free electron pair, and the positive charge at that nitrogen. But of course we have a resonance structure with the free electron pair at the carbon, but no charge anymore there. This carbon has an electron sextet, so it is a carbene, a very electron-rich carbene with a nucleophilic character, and this can react as a nucleophile with this aldehyde, resulting again in this Stetter ionic structure, positive charge here, or mesomerically stabilized. Also the positive charge can be here, but it is as a mesomeric system, it is distributed here. Also the sulfur is participating, but to a lower extent, because sulfur is an element of the third period. So negative charge here at the oxygen. Deprotonating here, that hydrogen is rather acidic, alpha to that iminium group. Deprotonating here, protonating there, and then we get to this structure with a very electron-rich double bond here. Now this center is highly nucleophilic, and well, that carbon, that carbon has been transformed. Here it is the electrophilic center. Now it has been transformed into a nucleophilic center, and this nucleophilic center can attack here in the beta position, the electrophilic beta position of the acrylonitrile, resulting in this intermediate. So the negative charge is stabilized by resonance structures with the nitrile group, but here an acidic hydrogen is offered sitting at the oxygen. This is deprotonated. The electron density will move towards the carbon-oxygen bond, forming the double bond simultaneously. This CC bond is broken in this direction. So Now the electron density here moves to that carbon. Here we have a double bond. This is protonated. Well, what do we get from that structure? It's again this nucleophilic carbene, returning to the catalytic cycle, and what has been formed from this part, this molecule, its structure D, our target molecule. Thanks for listening.